Today we are going to talk about TSN, which means time sensitive networking. TSN is a technology designed to guarantee reliable and timely data delivery in real time industrial systems. Let's start with a simple thought. What if a self-driving car's brake signal was delayed by just a small amount of time, say 10 milliseconds? What would probably happen? An accident. So, traditional Ethernet networks are designed for best effort delivery, meaning they try their best to send packets quickly, but there's no guarantee when they will arrive or if they will arrive at all. That's where TSN comes in. TSN takes the standard Ethernet and adds real-time reliability on top of it, ensuring that critical data always arrives on time. Why TSN is needed? In factories like robotics, automotive, and aerospace, timing is everything. These systems needs three things the most: low latency, meaning minimum delay; predictability, meaning every signal should arrive exactly when expected; and reliability, that data cannot be afforded to be lost. But traditional Ethernet have problems such as jitter, which is variation in packet arrival time, then packet loss, which means some messages don't make it to the end of the line, and no timing control because normal Ethernet lets any device send whatever it wants at any time. Standard Ethernet use SISMA or CD, which cannot guarantee delivery times. TSN solves this by scheduling traffic at the second layer. For example, imagine a robotic arm on a production line. If one signal arrives a few milliseconds late, the arm might move out of sync, leading to defects or even safety risks. TSN solved this by introducing deterministic communication, meaning data flows are scheduled, synchronized, and guaranteed. This is the visual comparison between traditional and TSN. We can see that in TSN, data arrives at timely orders, take it, without any difference between them. In traditional, we can see that data is arriving out of order. Now, let's look at what makes TSN so special. Key features of TSN. TSN isn't one single protocol, it's actually a suite of IEEE standards that upgrade Ethernet. Here are the main features. Time, uh, sorry, Traffic scheduling. Traffic scheduling. TSN introduces a time-aware shaper which decides when each type of message slash data is sent. For example, a braking signal in a car is sent before a music stream, ensuring critical data always have the priority. Next, reliability. TN uses redundant paths, i.e. more than one path. Data is sent on multiple routes and duplicates are eliminated at the receiving end. So even if one link fails, the message still arrives on time. Bounded latency. TSN defines a maximum delivery time. Packets can take longer than a known time limit. Example, in avionics, sensor data reaches the flight controller in microseconds. Next, time synchronization. All devices in the network share the same precise clock, synchronized using what is called a precision time protocol (PTP). In an automated factory, every robot arm moves at the exact same time because their clocks are perfectly aligned using PTP. Such as Industry 4.0, smart factories, or robotics, TSN enable robot sensors and controllers to communicate over one unified network instead of separate systems. Automotive car today have multiple systems, cameras, radars, braking, 360 cameras, which requires fast and timely. Aerospace avionics. TSN provides reliable data transfer for flight control system and avionics where time is a mission critical. Healthcare. Remote surgery and medical imaging rely on real-time precision. TSN ensures video and control signals have zero lag. To conclude, time-sensitive networking or TSN transforms traditional Ethernet into a reliable, deterministic, and time-aware network. It's the backbone of new industrial era.